So today we're going to look at two examples of word problems. The question itself, the first one, says the sum of two numbers is 12. The first number plus the second number is 58. Find the two numbers. Now, sometimes word problems can feel a little bit overwhelming, so I'm going to go with some strategies that can help you kind of figure out what it's asking about. So, what do we know? Well, the first sentence says the sum of two numbers is 12. And the is really just means equals. So I'm just going to write equals 12. So I don't know what either of the numbers are. And when we don't know what a number is, we're just going to let the first number equal x. So x is our variable. We don't know what that number is. There's multiple numbers that it could be, actually infinite number. There's an infinite number of numbers that could be, but I don't really know what it is yet. Then I need to find out what the second number is, because it says the sum of two numbers. So what is my second number? Now, I could just let it equal another variable, but I want to try and incorporate that piece where it says 12. So if we look at some examples, just over here as a side, we could have, for example, if the first number is 2, it's got to equal 12, so the second number would have to be 10, because 2 plus 10 is 12. If we had the first number is 3, then, 3 plus 9 is equal to 12. Again, if I look at, for example, 5 plus 7 is equal to 12. So I want to try and relate this as in x plus some number is equal to 12. So when I was looking up here at 2 plus 10 is equal to 12, notice that 12 minus my first number, which is 2, is equal to 10. Also notice over here that if I know that the sum of the numbers is 12 and I take away my first number, I get 9. And finally down here, if my sum is 12 and I take away my first number, which is 5, then I get 7. So in the same piece here, if I have 12 and I take away my first number, then I get my second number. Okay, so then I can come back here and say, well, let the first number be x, then the second number must be equal to 12 minus x. So that was just from our first sentence. The second sentence is telling us twice the first number plus the second number is 58. So let's just kind of break this down slowly. So twice the first number. I'm just going to use the hashtag for number. So twice the first number. So the first number is x. So that's 2x. And then it says plus the second number. Okay, well, twice the second number twice the first number plus the second number is means equals 58. So if I write this in an algebraic equation, we have twice the first number plus the second number, and it's plus the entire second number, which is 12 minus x. I'm putting it in brackets because I'm adding the entire second number, and this is all equal to 58. And the last sentence says, find the two numbers. The first number is, and I want to know what the second number is. So I'm going to solve for x, and then I can find out what the first number is, and using x I can find the second number. So here I have 2x, and I'm adding 12, and I'm adding negative x, and that's equal to 58. And then I can collect my like terms, and I get x plus 12 is equal to 58. And then, because we've been solving equations, we know that we're going to subtract 12 from both sides. and we get that x is equal to 46. Now, I've solved this, but this isn't my answer. So I have to go back up to the question and make sure I'm answering it. The two numbers. So I know that the first number we just solved for is 46. Now the second number is 12 minus 46. So we're doing 12 take away 46, which is equal to negative 34. So we're going to always write our answer in a conclusion. Word problems are in words, and our answer should be in words too. So the two numbers are 46 and negative 34. And now we're done that one. Alright, our second example is going to have to do with ages. So it says, a father is currently 3 times as old as his daughter. 8 years ago, the father was 5 times as old as his daughter. How old were they 8 years ago? Now, there's a lot of stuff going on here. So let's start to think about this. So I'm just going to make up, I'm talking about my father here, or the father. We've got the daughter. We're looking at their ages now and their ages then. And what I've actually created here is a little chart. Some lines in there. And the reason I've created this chart is so that I can have the father's age now in here, the daughter's age now in here, the father's age then in there, and finally the daughter's age then in there. Okay, so I'm going to start by looking just at the first sentence. A father is currently 3 times as old as his daughter. A father is currently 3 times as old as his daughter. Well, do I know how old the daughter is? No. So I'm going to let the daughter's age be x. Okay, so her age right now is x, which means that if the daughter is 3 times as old as her now, I can write 3 multiplied by x in that little box. We've now used all of the information in the sentence. The next thing that we see is that the next sentence is 8 years ago, the father was 5 times as old as his daughter. 8 years ago, the father was 5 times as old as his daughter. So we have to start thinking about this now and then thing. So just as a little side thing here. Okay, so we've got now, then, the father, the daughter. If the daughter was 9, okay, well that would mean that the father would be 27, because 3 times 9 is 27. 8 years ago, how old was the daughter? So I would just take 9 minus 8, and this would be equal to 1. So 8 years ago, the daughter was 1. And 8 years ago, the father was 27, his age now, minus 8 for 8 years ago, was 19. We're going to use the same concept for our boxes for the then. So 8 years ago, the daughter was x years old minus 8. And 8 years ago, the father was 3x, because that's his age now, and then we're going to take away 8 for 8 years ago. So we've used this piece 8 years ago, but we haven't used this 5 times as old. So the 5 times as old is going to be used so that we can create an equation. We want to be able to solve for the value of x, and that's what we've been doing in our classes so far. We've been solving for the values, and therefore we need to create an algebraic equation. Okay, so if we need to create an algebraic equation, then just think about this. So if Dad was 25 8 years ago, and the daughter was 5 years ago, and Dad was 5 times as old, notice that if I took the daughter's age and multiplied it by 5 for the 5 times as old, this would make this a proper equation because 25 does equal 25. So using this idea, we're going to do it with variables. So if I know that the father is 5 times as old as the daughter, that means the father's age is 5 times more already. So this 3x minus 8 is 5 times more than the daughter, which is why we have to put it over here because her age is smaller. So to make their ages equal, I need to multiply her age by 5. Now with that said, we can solve. So we have 3x minus 8 is equal to, now remember we've got to distribute this, so we have 5x minus 5 times 8 is 40. And now because I'm going to solve this, I'm going to add 8 to both sides. I'm going to subtract 5 from both sides. Could have done it the other way as well. Negative 2x is equal to negative 32. Next thing we want to do is divide both sides here by negative 2 because we want to know what x equals. We get x equals 16. So we solved for x, but we still haven't answered the question. Go back up to the question and it says, how old were they 8 years ago? Well, I just solved that x equals 16. Okay, which means right now Dad is 3 times 16, which is just equal to 48. And then I'm just going to subtract 8 years. So Dad is equal to 40. You could also substitute 16 in here and you would still get 40. And the same thing here, I can do 16 minus 8 is equal to 8. And I need to have a conclusion. It's a word problem, so we always answer with words. How old were they 8 years ago? Dad was 40, daughter was 8. Dad was 40 and daughter was 8 years ago. And let's just put a little circle around that so that we know that we did it.